Okay, sorry, we kind of got cut off. I wanted to make sure that you understood that because this point is not a solution, that I want to shade the opposite half plane. So I'm going to shade below the line because this point is not a solution. All right, so next example. If I'm asked to graph the inequality, I need to start by graphing my boundary line. So x is less than or equal to 10. This tells me that I'm looking at all of my x values. So just like if we had the line that said x equals 10, that means all of my x values are 10. So it works in the same way. So my boundary line is going to be a vertical line at x equals 10 because every x value equals 10. And I know in this case it's going to be a excuse me, solid line because it says less than or equal to. I'm going to draw my boundary line, a solid line at x equals 10. That solid line shows that it's the line itself is part of my solution set. And now I'm going to shade everything to the left, everything that's less than 10. Now, vice versa, if I have an inequality like y is greater than -2, then that means all of my y values are -2. So I'm going to graph the line y equals -2. And I know that y, oops, I apologize. I know that y is going to be greater than -2, and I need a dashed line in this case because I don't have the equal to part on my symbol. And my pen tool's not working. There we go. So I have a dashed line here, and I'm going to shade everything that is greater than -2. So keep an eye out for your vertical and horizontal lines. Now, if I have to start with a graph and come up with the inequality myself, I know that I need to start by finding the inequality for my boundary line. So I'm going to look at this line, and I see a couple things happening. I see a y-intercept of -2, but I also see these 2 points labeled. So I have 2, -1, and -2, -3. I'm going to go ahead and use these 2 points just to make sure that I'm calculating the right slope and y-intercept. So I'm going to use these 2 points, and from this point to this point, I'm going to rise 2 and run 1, 2, 3, 4. So if my slope is 2/4, that would reduce to 1/2. So now I can tell that this would be the exact location of my y-intercept because I can rise 1, run 2. So my equation, because I have a solid line, my equation is going to be y is less than or equal to mx plus b. M is 1/2 and my b is -2. So my boundary line is giving me all of my information for writing my inequality for the graph. Let's check out number 8. Right off the bat, I noticed the dashed line. So I also see shading above that line. So I know the symbol that I'm going to need is going to be a greater than. So I need to find my M and I need to find my B. Now I can tell right here that my y-intercept is going to be a difficult location to pinpoint, and I can't do it just by looking at my graph, so I'm going to have to use some substitution. So I'm going to scroll down and give myself a little more space. Using the 2 points given, 4, -2, and -4, 4, I'm going to calculate my slope. So from one point to the next, that's a rise of -1, 2, 3. and a run of 1, 2, 3, 4. So I have my slope, and I don't know my y-intercept, so I'm going to use one of my points to substitute in here and help me find my y-intercept. So I'm going to go ahead and use the point 4, -2. So I'm going to put 4 in for x. And I'm going to put -2 in for y. And now I'm going to solve. So -3/4 times 4, my 4's will cancel. So I'm left with -2 is greater than -3 plus b. And now I'm going to add 3 to both sides. And I have +1 is greater than b. So my b is going to be 1. So my new equation will be, let's write this in green, y is greater than -3/4 x plus 1. And looking at my graph, I can see that 1 does make sense for this y-intercept because my scale is counting by 3. So as I start at 0 here, or I'm sorry, I'm counting by 2. So I have 2, 4, 6. So this does look like a +1 would make sense. But even though it looks like 1, I need to test it algebraically to make sure that I give an exact location for it. So that is my inequality, -3/4. Let's write that up here too, plus 1. All right, we can't leave word problems off, so let's practice a word problem here. To keep in shape, you try to swim and run at least 6 hours a week. Let X represent the amount of time you spend swimming in 1 week, and let Y represent the amount of time you spend running in 1 week. Write an inequality that describes the number of hours you exercise each week in terms of X and Y. So I'm going to take this part here, at least 6 hours. So when I run and swim together, I want to hit at least 6. So 6 will be the very smallest, and it could be equal to 6. So I'm going to be looking at less than or equal to 6. Or I'm sorry, greater than or equal to 6. And that will give me at least 6. So X is the amount of time I spend swimming. Y is the amount of time I spend running. So this would be my inequality for the amount of time I spend exercising each week. If I want to graph this inequality, then I need to take it and solve it for y. So to do that, I'm going to subtract x from both sides. X minus x cancels, so I'm left with y. And I'm going to try to put this in y equals mx plus b form. So I'm going to put my x term first. That will make it nice and easy to graph. So I'm going to start by graphing my y-intercept, which is +6. And I have a slope of -1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And as I draw my line, I'm going to do a solid line because I have greater than or equal to. And now as I look at my shading, I need to shade, I need to do a couple test points here. So it says give 3 possible combinations of hours that allow you to meet your goal. So let's pick a test point so we can see how to shade. So I'm going to use red for my test point. So let's just do the point 1, 1 again. If I put 1 in for x and 1 in for y, Let's solve and see if this makes a true statement so I know if this is a part of my solution. So -1 plus 6 is 5. 1 is not greater than or equal to 5. So this point is not a part of my solution set. So I need to shade the other half plane. So if I need to list then 3 possible combinations of hours that will allow me to meet my goal, I could include a point on my line because my line is solid, which means it's included in my solution set. So let's choose one of those. So I could spend 3 hours swimming and 3 hours running and meet my goal. And any other point that is in this shaded area would work as well. So for this point is 6 hours of swimming to 3 hours of running. Or I could look at this point. This point is 3 hours of swimming to 6 hours of running. So those would be 3 possible combinations of hours that allow me to meet my goal. And you are all set for your homework, your 6.7 worksheets. And you are going to do numbers 2 through 8 all, and then numbers 10 through 26 evens. You will do great.